Okay, let's solve this guy. So I'm just going to copy it down again so I have more space. And I'm going to copy it down with its factored format. And the first thing I'm going to do is clear the fractions. My common denominator is going to be the x plus 3, x minus 2. And so I'm going to multiply everybody by that x plus 3, x minus 2. And then cancel. So the x minus 3's cancel. And then with that 6, I distribute. And so I'm going to get left over 6x minus 12. Cancel the x minus 2. Let's do that in red. The x minus 2's cancel. Then distribute, and very carefully you are distributing -5. You are take that minus sign there and distribute that -5. So I have minus 5x, minus 15, and then on the end, everything cancels for minus 25. And now we will just finish from there and see what we get. Combine like terms. 6x minus 5x will be x. Negative 15 minus 25, or excuse me, negative 12 minus 25. Negative 27 equals negative 25. Add the 27 to both sides. And we get x equal 2. But it's still right up there. X equal 2 is a restriction. And so we say no solution. And however you want to indicate that to me. Now on the computer, they probably will say something like if there's no solution, type an N. Sometimes some people use the empty set symbol. However you want to communicate it to me is fine. On a test, if it's a test I'm actually grading, just write no solution. But since that was a restriction, there's no solution. Now we can actually think about checking this, and that's what we'll do on the next page. We're going to check it. It's a really bad graph as I look at this, so I'll highlight the graph when we actually bring up the next page. But we can still check it doing the same way that we've checked the other guys. So checking this graphically, so it's doing the same thing, pulling everything over to the other side. Notice I don't have to worry about my factoring, just pull it over to one side, press my y equals key, and type everything in using careful parentheses. Those entire denominators need to go in parentheses, then press zoom 6. Now here's why it's a bad graph. You can barely see it, so I'll highlight what the graph is doing. That it's like this. It's doing that. And it's doing that. And when I look at it, there are no x-intercepts. And so that's what we see on the last phrase here. Because we found no solution, there should be no x-intercepts, and they're not. And so it is the no solution part is not checking. Now this graph is actually a little misleading. We came up with, there's 2 right there. At -3, there's an asymptote. What's really happening at 2, and we just can't see it from the graph, is there's an itty bitty tiny missing point. Now you don't need to remember that, that's not important for our work here. But what's important here is we came up with no solution and there are no x-intercepts. So you can even check that no solution thing. Okay, moving on to the next topic. Recognizing identities, conditional equations, and inconsistent equations. So the very first problem we did was this guy. and we got the answer -7/4. And the instructions had read to that guy, what is the solution? Select the correct choice below if necessary. Fill in the answer box to complete it. And those were my choices, and we wrote in -7/4. Because we got an answer, when a linear equation has one solution, we say that this is a conditional equation. So we solved it just as normal. And then when we got a nice, neat answer, even though it was a fraction, we still got an answer. That is a conditional equation. So when a linear equation has one solution, we say it's a conditional equation. And so that guy was a conditional equation. When the last example we just did, example 4, if we'd been given those same answer choices, we weren't, but if we'd been given the same answer choices, remember we found that it had no solution. The above equation is found to not have a solution. If we'd been given those same choices, we would have selected that the solution set is the empty set. That this symbol right there means empty set. Which just means you don't have anything. There's nothing. Was there a solution? No, there wasn't. There was no solution. There was nothing. And so if we had been given those choices, we would have picked C, that the solution is the empty set. And then when an equation does not have a solution, it's called inconsistent. And so we would have called, if asked, we would have called this equation inconsistent because it did not have a solution. So there's one other type of thing. So the headline here was recognizing identities, conditional equations, inconsistent equations. When your equation has one solution, when we're talking about linear equations and you have one solution, it's conditional. When you don't have a solution at all, it's called inconsistent. So the last thing we have to recognize is this thing called an identity. And so there is another equation that, well, we still will get there. Okay, I jumped ahead. Forget I said that. Pretend it didn't happen. And that happens with the videos, because unless I make a major mistake, I don't re-record. We will get to the identities momentarily, but another way that we can have an inconsistent equation. So let's solve the following here. And this one's a little easier than some of the things we have been doing. We'll distribute here. And we get 3x minus 5 equals 4x minus 8 minus x. Combine like terms. And so I've got 3x minus 5 equals 3x minus 8. Get those x's together, and they cancel, and I get -5 equals -8. No variable, and false. At least in the world that we generally live in, -5 does not equal -8. When that happens, that means that our original equation is inconsistent. So there's another way that an equation can be inconsistent. Again, it's still the same idea. You didn't get a solution. We got a perfectly ridiculous statement, -5 equals -8, but you didn't get a solution, and so it's inconsistent. So that's just another way to recognize an inconsistent equation. So when solving an equation results in no variable terms and a false statement, the equation is called inconsistent. But it really is sort of the same idea. You didn't get an answer. If you don't get an answer, it's inconsistent. So this guy is inconsistent, and if we had had these choices here, you didn't get an answer, we would have picked C. Okay, let's look at another problem. Solve the following. So I'm going to clear my parentheses first. And let's go off to the side here. 4 times 1/8 is 4/8, which is 1/2. So I'm going to get 1/2 x minus 12 equals 1/2 x minus 12. Now you could go further, but notice both sides are identical. Identical. Spell it right. Spelling is not my strong suit. Identical. I think that's how you spell identical. Identical. I think so. No, it's not. There we go. We'll get it right. Like I said, spelling's not my strong suit. Too bad they don't have spell checkers for when you're writing things by hand. Both sides are identical. When that happens, when you're solving an equation and both the left sides and right sides of the equation being identical is called an identity. So the above equation is an identity. Is an identity because both sides were identical. And if we are given these choices here, we would select B. Because what an identity is saying is that you can put any value of x in there and both sides will come out being the same because both sides really are identical. So any value of x will work. So summarizing, if a linear equation has one solution, it's said to be a conditional equation. If an equation has no solution, or if solving results in no variable terms in a false statement, it's said to be inconsistent. When solving the equation, if the left and right sides of the equation become identical, the equation is said to be an identity. So, example 5 here, solve the equation, then determine whether the equation is an identity, a conditional equation, or an inconsistent equation. So first thing we're going to do is clear I think we're at 13 minutes on this video, so I think we'll end this video and we'll pick up solving this equation.